So now we're going to practice graphing some more piecewise defined functions. So I have another piecewise defined function, and I am going to pop over to my Desmos calculator. I have a whole bunch of things I've already typed in. I'm going to go ahead and get rid of some of the points. This one I'm just going to be a little lazy and just type in my new one, 1 plus x for that one. And the function is x is less than 0. And then for the other function, I have x squared. So I just type x and then the caret and then squared. And delete all the rest of that stuff. And my function domain is going to be x is greater than or equal to 0. Excellent. Now, remember I zoomed out on my last problem, so if you click this home button, it'll default back to the regular zoom so you can see it better. On the blue function, I have a closed dot here at 0, 0. So I'm going to go ahead and type that in. And that's a blue, so I click and hold this. I'm going to change it to blue and keep it closed. And I have an open circle on my red. So right here I have an open circle at 0, 1. And I'm just clicking on the point to find out if it's what the value is. But then I need to decide that this was coming from my red function, and because it's strictly less than, it's not closed, it's open, so I have to mark that. I have to do that manually. So this is what my graph looks like. I have a quadratic coming up and a linear going to the left. And I'm going to go back to my picture and kind of sketch that for you. So we start here at 1 for my red function. And it goes like down. And then from my blue function, I have a closed circle at 0, 0. And then it goes up. So what is my domain? So for this problem, my red arrows are going left forever and down forever. My right arrows are going right forever and up forever. So because I'm hitting every x value all the way to the left, all the way red values, red values, red values, and exactly at 0, my red value jumps down to be my blue value, and I don't miss a beat. There's no value I'm missing in my x direction. I am truly going left forever and right forever, and I don't miss a beat in the middle. Okay, so for my range, I'm also going down forever and up forever. And in this case, I have negative infinity going down forever, and I have y values, y values, y values all the way up, and then the red jumps down from a positive 1 down to a 0, so I don't miss any y values there. So my domain and range are both all real numbers. To find f of 3, you could probably plug it in if you want, or you could look at the graph carefully if you want. I'm going to go back to my picture and I'm looking for f of 3. So right here at 3, I can see that it hits at 9. If that's hard to see because it's kind of like scrolling a little bit, what we could do is just type what happens when x equals 3. And then we can see exactly it's 9. So that was a pretty simple answer. F of 3 equals 9. What about f of 0? I'm just going to pop back over and change that to 0 and see what happens. Okay, this one's a little trickier. Now this one's a little trickier because we have a blue dot and a red dot. But remember, we're talking about the closed circle, so it's 0. So f of 0 is 0. What are the values of x for which f of x equals 2? So I'm going to pop back over here, I'm going to delete that out, and I'm just going to use f of x equals 2. And where that line, and I don't want it to be red, I want it to be another color. Let's do purple, okay? So where does this purple line hit either my red or my blue? Well, right there, 1.414. So when I'm asked, what are the values of x for which f of x equals 2, I can write x equals 1.414. Alright, so my next example has 3 equations in the piecewise defined function. So I'm going to come over here and delete some of this out. Okay, I have all this typed in now, and so I have the 3 function values, and I have this 0.2, 0, 2 there, which is that blue function. It's kind of grayed out a little bit, and so I'm going to make sure that it's nice and clear at 0, 2, and I'm going to make that the blue dot. On the red, I have to have endpoints here, so I'm going to make endpoints at -3, 0 for red. I'm going to make that red, and it's a closed circle. And then I have at 0, 3 in red, I have an open circle. So I'm going to hold that, make it red, and make it open. So I have a closed circle at -3, 0, and then open at 0, 3. I've got a blue closed dot at 0, 2 for my second function, and then my green function at 0, 0, right there, 0, 0, it says undefined because it should be undefined there. So at 0, 0, that is my green function. And because it's strictly greater than, not equal to, I have an open circle. And so that is the picture of my graph. I'm going to pop over here and go ahead and graph that for you. So at -3 in my red function, I have a closed dot all the way up to the open dot right here. In the green, I have 0, 2, and in the blue, it was the open circle at 0, 0, and then that square root. So my domain for this problem starts at -3. It's a bracket, it's a closed bracket because we are allowed to equal -3. And then it goes from -3 and it hits all of the values, including 0, all the way up towards infinity. So -3 to infinity. The range, the lowest y value we can have, is 0, and it goes up towards infinity and it meets every single other value, so 0 to infinity. Next, we're looking for what are the function value in f of x for f of -1. So that's x equals -1. So I'm going to pop over to my graph again and just type in x equals -1. Where does that hit? Well, it hits right there, and I'm going to change that color to a different color. So right there is at -1, +2. Therefore, f of -1 is +2. You can probably also see that right there on the graph. Okay. How about f of 0? Well, that one is also 2 because, and if we can look at the graph here, if we change that to 0, you can see that vertical line is going through, but it's only equal at the 2. So let me move that away for just a second. So if I turn it off, you can see that it's closed at 2 but open at the other 2 spots. So the value is equal to 2. And then what are the values of x for which f of x equals 2? So then I'm going to come and type in f of x equals 2. And notice that's a horizontal line.
And notice that it touches 3 times. It touches at x equals 1 on the red, x equals 0 on the blue, and x equals 4 on the green. So when I come back over here, it says what are the values? And the reason it says values is because there's more than one. We have x equals -1, 0, and 4.